Aldehydes and ketones are organic compounds that contain carbon-oxygen double bonds. That is, the carbonyl group as a functional group. They have the general molecular formula CnH2NO. Aldehydes and ketones closely resemble each other in most of their chemical properties. Hence, they are often collectively referred to as carbonyl compounds. However, aldehydes and ketones differ in the nature of the groups that are attached to the carbonyl group. In aldehydes, one of the two available valencies of the carbonyl group carbon is essentially satisfied by an H atom, and the other by a hydrogen atom, an alkyl group or an aryl group. Hence, the general formula for aldehydes is RC double bond OH. If R is H, then the corresponding aldehyde is formaldehyde. If R is the methyl group, then it is an acetaldehyde. And if R is the phenyl group, then it is a benzaldehyde. In ketones, the two valencies of the carbonyl group are satisfied by two alkyl or aryl groups, R and R', which may be the same or different. If R and R' both represent the same group, then the ketone is called a simple ketone. If R and R' are different, then the ketone is called a mixed ketone. The general formula for ketones is RC double bond OR'. For example, acetone represents a simple ketone where both R and R' are the same. That is, CH3. Benzophenone, where both R and R' are C6H5, also represents a simple ketone. On the other hand, acetophenone, where R is a methyl group and R' is a phenyl group, represents a mixed ketone. Due to this difference in the nature of the groups attached to the carbonyl group, in aldehydes and ketones, their reactivity is different. For example, aldehydes oxidize with ease as compared to ketones. Let us now look at the significance of these compounds. Aldehydes and ketones are well known for their fragrance and flavor. For example, the smell of acetaldehyde is reminiscent of apples. Also, vanillin from vanilla beans, salicylaldehyde from meadows sweet, and cinnamaldehyde from cinnamon have very pleasant fragrances. Aldehydes and ketones both find significance in several biochemical processes. For example, glucose, a polyhydroxyaldehyde, is the chief product in photosynthesis. Respiration, which takes place via the combustion of glucose, is associated with the liberation of energy. Thus, it is the ultimate source of energy in plants and animals. These compounds have considerable industrial significance. They are used as solvents and as starting material for the synthesis of several other products. For example, acetone and ethyl-methyl ketone are common industrial solvents. Formaldehyde is used to prepare bakelite. Urea formaldehyde glues and other polymeric products. Acetaldehyde is chiefly used as starting material for the synthesis of acetic acid. Ethyl acetate, drugs, and polymers. Benzaldehyde is used in the perfume and dye industries. Certain compounds are used for preparing adhesives, paints, resins, plastics, fabrics, and so on. Like other organic compounds, aldehydes and ketones also have two systems of nomenclature. They are the common system and the IUPAC system. The common names of aldehydes are derived from the names of the corresponding carboxylic acids that they form on oxidation. They are named by replacing the IC acid of carboxylic acid by aldehyde. Thus, the aldehydes formaldehyde, acetaldehyde, and benzaldehyde are named after formic acid, acetic acid, and benzoic acid respectively. As you can see, they are named by replacing the suffix IC acid with aldehyde. The positions of the side chains or substituents in the carbon chain of aldehydes are indicated by the Greek letters alpha, beta, gamma, and delta. The carbon that is directly linked to the aldehyde group is alpha carbon. The next carbon is beta carbon, and so on. For example, the given compounds can be named alpha-hydroxybutylaldehyde and beta-bromobutyraldehyde respectively. In the IUPAC system, aldehydes are named by replacing the E of the corresponding alkane by Al. Hence, the IUPAC name for aldehydes is alkanal. For example, the IUPAC name for formaldehyde can be written by replacing the letter E of the corresponding alkane methane by Al. Hence, the IUPAC name for formaldehyde is methanal. Similarly, the IUPAC names for acetaldehyde, propionaldehyde, N-butyraldehyde, isobutyraldehyde, and valeraldehyde are ethanal, propanal, butanal, 2-methyl-propanal, and pentanal respectively. The substituents in the aldehydes are prefixed in alphabetical order along with numerals indicating their positions in the carbon chains. Thus, the IUPAC name of the given compound can be written as 3-bromo-2-chloro-4-methyl-hexanal. In case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehyde group. Thus, the given compound is named 2-ethyl-3-methyl-pentanal. It must be noted that the C2 of the IUPAC name corresponds to the alpha of the common name. For example, the compound shown here bears the IUPAC name of 2-methyl-pentanal, while its common name is alpha-methyl-valeraldehyde. Here is a list of some aldehydes with their common and IUPAC names. From the list, you can see that the IUPAC name for alpha-chloroacetaldehyde is 2-chloroethanal and for acrolein it is propanol. In the IUPAC system, when the aldehyde group is attached to the ring, the suffix carbaldehyde is added after the name of the cycloalkane. For example, in cyclohexanaldehyde, the aldehyde group is attached to a 6-member cyclohexane ring. Hence, its IUPAC name can be written by adding the suffix carbaldehyde to the cyclohexane. That is, cyclohexane carbonaldehyde. Similarly, the IUPAC name for benzaldehyde can be written as benzene carbaldehyde. Note that the common name benzaldehyde is also accepted by IUPAC. To indicate the substituent on the ring, the numbering of the ring starts from the carbon atom to which the aldehyde group is attached. For example, the IUPAC name for gamma-methyl cyclohexanaldehyde is 3-methyl cyclohexane carbaldehyde. Similarly, while writing the IUPAC name for orthohydroxybenzaldehyde or salicylaldehyde, the substituent hydroxyl group gets the second position as the numbering of the ring starts from the carbon atom attached to the aldehyde group. Thus, the IUPAC name for this molecule is 2-hydroxybenzene carbaldehyde. Now let's look at the common names and the IUPAC names of some compounds. The common name, metachlorobenzaldehyde, is written as 3-chlorobenzene carbaldehyde in the IUPAC system. Similarly, para-nitrobenzaldehyde is 4-nitrobenzene carbaldehyde. Phthalaldehyde is benzene 1,2-dicarbaldehyde. Vanillin is 4-hydroxy,3-methoxybenzene carbaldehyde. Crotonaldehyde is 2-butanal and cinnamaldehyde is 3-phenyl-propanol. Let us now turn our focus to the nomenclature of ketones. In the common system, ketones are named simply by adding the suffix ketone to the name of the two alkyl groups. In case of simple ketones, where both the alkyl groups are the same, the prefix di is used for the alkyl group. For example, the compound CH3 C-double-bond-O, CH3, is named dimethyl ketone or simply acetone, while C2H5 C-double-bond-O, C2H5 is named diethyl ketone. In case of mixed ketones, the two different alkyl groups R and R' are mentioned in alphabetical order. For example, the compound CH3 C-double-bond-OC2H5 is named ethyl-methyl ketone. Similarly, CH3 C-double-bond-OC3H7 is named methyl N-propyl ketone. The positions of substituents in ketones are indicated by the Greek letters alpha, alpha dash, and beta, beta dash, and so on, where alpha, alpha dash are given to the carbon atoms adjacent to the keto group. For example, in the given molecule, the substituents, 2 bromine atoms, are present on the alpha dash and beta carbons. Hence, it is named alpha dash beta dibromodiethyl ketone. Alkyl phenyl ketones are usually named by adding the acyl group as a prefix to phenone. For example, when CH3 C-double-bond-O is attached to benzene ring, it is named acetophenone. Similarly, the molecule C2H5, C double bond O, C6H5 is named propiophenone. The ketone in which a carbonyl group is attached to two benzene rings is named benzophenone. According to the IUPAC system, ketones are named by replacing the E of the corresponding alkane with -one. The longest chain carrying the carbonyl group is considered the parent chain, and the numbering begins from the end nearer to the carbonyl group. The compound shown here is named 4-methyl-hexane 3,1. In certain polyfunctional compounds, if the carbonyl functional group of the ketone is present as a substituent, then it can be indicated by the prefix oxo, and a number is indicated to show its position in a molecule. The example here contains three functional groups: hydroxyl, aldehyde, and ketone. According to IUPAC rules, as the order of preference while naming is aldehyde, ketone, and then hydroxy, the carbonyl functional group of the ketone and the hydroxyl group of the alcohol are treated as substituents. Hence, the IUPAC name is 5-hydroxy 4-oxohexanal.